Alright, part 3 of this 2.1.6 truss force practice problem. We're doing the rest of the internal forces on the members. So, just to recap, part 1 was external forces using our reaction forces and the known values. We found all the reaction forces and all those external forces, R, A, X, Y, and so on. We put them in a nice neat table. Part 2, we started looking at the internal forces. So what forces were acting inside the members of the truss. We got as far as using the joint A using method of joints. At joint A, we were able to solve the internal force of member AB and AD. And I concluded that second video saying we need to move to joint C so that we can determine the internal forces of members BC and DC. So here we are. First thing we always do is free body diagram, which I've got started here. The two members BC and DC, along with our joint, the only external force we have was reaction force of C in the Y direction. If you look at the table from above, which is in video 1, we found that reaction force is 150 pounds. So every time we do a method of joints and we pick a joint, the first thing we do is summation of the forces. I'm going to do in the Y direction. So we need those to equal 0, so we have equilibrium. We're going to say 0 is equal to, well, the only forces we have in the Y direction are reaction force of C in the Y direction, and then some portion of BC, the force of member BC. So if we look at that, BC, there we go. I'm going to break this into its components, and that's going to point up and to the left. This is BC, whoops. Yeah, BC in the Y direction. This is, I guess I call it CD, so I'll start calling it that more in the X direction. Oh, what am I doing? BC in the Y direction, BC in the X direction. There we go. We're not on to CD quite yet. Too many unknowns. And then our angle was 29.745. There we go. Squeeze that in. So the hypotenuse is magnitude of member BC. Looking at this, we have reaction force of C in the Y direction. We also have, well, in the Y direction we're positive, right? Our arrow is pointing up and to the left. So it looks like we've got BC in the Y direction. Well, if you look at that, BC in the Y direction is just simply the magnitude of BC times sine of 29.745 degrees. While we're at it, we may as well do BC in the X direction, which is just the full member BC times cosine of the angle 29.745. So again, that's just simple trig. Sine of 29 is BCY over BC. So to get BCY by itself, we find that it's just the full magnitude BC times sine 29. And same thing for cosine. Cosine goes with your X direction. So the reason we do that is we can actually then use substitution and say that reaction force C, actually you know what, I'm just going to substitute already. 150 pound force, which is RCY, plus BCY. Well, BCY we just said was equal to BC sine of 29.745. And the reason we do that is we can now see BC is one of the answers we're looking for. BC, not BCX and BCY, but just BC. So what I'm going to do with that is I'm going to move this to negative 150 to the left is equal to BC times sine of 29.745 degrees. So BC is equal to negative 150 over sine of 29.745. So BC is negative 302 pound force. So, as always, we get a negative number for an internal force. What that means is that our initial assumption that it was in tension is wrong. So we answer that BC as a positive 302, and then we just note in parentheses that that is in compression. Next, we're moving right along here. We're going to do the summation of the forces in the x direction. Set them to 0, and we find that negative CD, remember CD is directly left, right along the x-axis, so there's no trigonometry involved. We also, though, I was about to say that our BCX, BC in the x direction, I was about to say this is negative because it's pointing left. But the problem is, we just found out that we were wrong in our assumption that it went this way. Okay, so we need to rewrite our arrows. I'll even use red arrows. We're going to update our arrows to say down and to the right. Okay, so because it's pointing to the right, we do actually get to go back and say plus BC in the x direction. So we've already found what BCX is in terms of just BC. And that's going to help us out a lot because we can say negative CD plus BC times cosine of 29.745. And then we move CD is equal to BC cosine 29.745 degrees, and then we solve that by subbing in the BC from here, 302. Can we keep that positive? Cosine of 29.5 degrees. CD is equal to 262.5 pound force. So, again, positive. We assumed correctly that it was in tension. I'm going to come back up here and write 262 pound force. Well, I should have been putting pound force in all these. Let's see if I can't do that right now. I got most of them. Let's rewrite that. That was in compression. Alright, so always put labels. I catch myself missing that a few times too, so don't be afraid to call me out on it if I ever do, but do try and put units on all of your answers here. So we are to a point where we've got 4 of the 5 members solved for. So let's look at D. Joint D. Okay. Moving on to that member BD, and looks like we have it mostly updated here. In fact, I'm just going to redraw this whole thing. There we go. Because what I found is we have BD, we have forces acting this way. In terms of, let me actually redo that one. In terms of our external forces, we have one external force here, and that was just force at D, which was 500 pound force. Okay, and that's, I'm just going to go clear back to the original problem. It's this force right here. It's the initial external force, 500 pounds, that was applied to our truss. So, in coming back, we have force of CD and AD left and right. But if you look at our joint D, here's our medium D here. If you sum our forces in the y direction and set them equal to 0, what you find is very easily that force of BD, that was supposed to be a D there. Right, let me just double check that. Up here, yeah, that's BD in the middle. So we have member BD, we have that pointing straight up, and that is our only other force. Right, so force of D is straight down, so I apologize, that's a negative F. D. Yeah. Okay, sorry about that. Let me regather my thoughts here. So we have the summation of the forces in the y direction. We have force BD pointing straight up. We have force of D, which is our external force of 500 pounds, pointed straight down. So we have our negative force in the D plus the member force BD equal to 0. If we substitute what we know, negative 500 pound force straight down plus the internal force of BD equals 0. BD then just simply equals 500 pounds and we're done. It's positive, so we know it's in tension. We don't have to switch anything. We can come up here, we can update this to say 500 pound force of tension, and we have our internal and external forces done. So when a problem says calculate all truss forces, or calculate all external and internal forces, or solve the truss, this is what it's asking for. The key points to remember are keep a nice clean table off to the side for your external forces, then run your sum of the moments, your sum of the forces in the x and y directions, get all of your external forces, then move to your internal forces. Internal forces are going to be assumed all in tension until you find an answer to be negative. And when it is negative, such as this negative 438, that means that it was actually in compression. So your answer is positive, but you note it in compression. So again, keeping a nice clean table off to the side for your internal forces, just like you did external. And that's it. That is how you solve for a truss.